n over 2 multiplied by n plus 1. Okay? And I did that, and then I plugged in n over 2 multiplied by n plus 1. So, of course, if you add 1 plus 2, you get 3. So 1 plus 2 means that you're stopping at 2. So 2 over 2 is 1. 2 plus 1 is 3. So 3 times 1 is 3. That's the answer right there. And you can plug in any number, even a million, okay, which certainly even a computer will take some little time to do that. But there is one that could take the computer an impossible time to do. Okay? But this formula can do it. Because all you need is, you find a number where you start. Suppose it's 10 to the power a million. Okay? 10 to the power a million. That's going to take a computer a lot of time to do that. But all you need is you have your 10 to the power a million, you divide it by 2, add 1 to it, and and then maybe I don't. Yeah. Okay. The formula that I'm talking about is okay. Thank you. What I'm talking about is the sum. If you're adding 1 plus 2 plus 3 plus to n, okay, say that is equal to, okay, s of n. S of n is equal to n over 2 n plus 1. This is what I found in the high school. And like I said, if, let's say n was equal to 10 to the power a million, okay, to 10 to the power 6. You try giving that to the computer, though. I mean, let the computer add that kind of number. That's going to be horrible. But technically, you will have that as s 10 to the power 6 is equal to, you just substitute it here, 10 to the power 10 to the power 6 over 2 into 10 to the power 10 to the power 6 plus 1. That's an answer. The computer will have a difficult time trying to do that. It will be crunching. You may run out of energy before it gets to do that. So that is the power of transformation. Okay? There is a transformation. You transform this difficult problem into a space where it's very neat and simple. And that's the basis of the unified field theory. It turned out that this formula that I did in high school was the same formula when I took it to my teacher. I guess he was a Frenchman. He looked at it and he basically, he gasped, and I think he almost had a heart attack when he saw that. He was the math teacher. And he said to me, "Do you know what you just did?" And I said, "No, I don't know. I thought I just found the formula." And he said, "Does the name Gauss mean anything to you?" This is Gauss. "Does the name Gauss mean anything to you?" I said, "No. I have no idea who he is." But he says Gauss is considered, along with Newton, okay, and Euler. Of course, he was a European, or he's a European. These are the greatest mathematicians of all time: Gauss, Newton, Euler. And this guy came to fame by finding this formula. This was his thing his claim to fame, as they say. So how did you do it? He says to me. I said, I just sat down and I looked at that and I put that end down. I tried to do some little serious thing, and that's what came up. So from then, of course, I would earned a nickname of Mr. Calculus. That was my nickname in high school. By the time, of course, I got to 10th grade, I became a teacher of calculus. Okay? So you would have thought that I was going to be teaching, you know, 9th grade is where people start calculus, teach 9th grade. But I wasn't teaching 9th grade. I was not teaching 10th grade. I was teaching 12th grade. And actually it was what they call popular demand by the people in the 12th grade who were my seniors. And the boarding school that I went to, being a senior was a very significant thing. I had to wash their clothes, at least up until that point. You know, I do the laundry for them. I mean, you know, because they were 2 years ahead of me. In fact, even 11th graders, you know, that's the tradition in the high school. So, but when it came to being a teacher, they had no problem, you know, say, yeah, let that young man come and teach us calculus. So they would take me there, and but I was rather small, so there was a little chair that I had to stand on to give my lessons. But it was fun, you know, they had fun just as I had fun. So, but, you know, this name stood with me throughout. As a matter of fact, there are some of my classmates that still address me with that name. One wrote me a letter a couple of years ago, and I still remember that, you know, after 30-something years. So the kinds of circumstances that surround the search, but part and parcel of this kind of development in terms of mathematics is the philosophy from the elders, the African philosophy, which was luckily quite, alive and well in the environment that I grew up. Okay, you were taught your history. You were taught who you were. You were taught about the war you lost 500 years ago. Okay, and how you became a POW, a set of POW, in 3 categories. One that were left on the continent, one that were dumped in the Atlantic Ocean, and one that came to the New World and other places. And so you know, in other words, you were geometrically and spiritually in a plane where you had information. You were quite and then the other thing they would have us do is to trace our ancestry. Okay, back as far as you can. Okay, I can easily trace mine to 1100, and by projection back to the pyramid years, Egypt. Okay, and so every young person, to show that you grew up well, that you are a true black person, you're an African, and that knows him or herself, you have to embark on doing stuff like that. So you're not just black and proud, per se. You're black and proud because of the glory of the Almighty God that blessed you with so much. Okay, so much food, so much knowledge, so much mathematics, so much civilization, in the cradle of civilization, so much history, so much love for humanity and all that. So you got to go through this. And what that does is really keep you continuously in a state of positive experience. And that, nourishes your development. It energizes you in terms of your growth, academically, spiritual, and so on. So all that added to the search for the unified field theory. So with things like this, I would move on to the university, and one of the pieces that was done in the undergraduate was a study of the rocket. I did in a book called, it's a published book, okay, the gas turbine testing, okay, by myself. I basically studied the principles of rocketry and how math plays a role in that, okay? And I remember a professor by the name of Professor Peter Wojcik, okay? A very brilliant Polish professor described this piece as a masterpiece. Those were his word. That was his word in describing the gas turbine testing. So again, there was an application of mathematics, the philosophy, the African philosophy, and you know, and the appreciation of what the giver of knowledge, who is the Almighty God, has done. So then we moved on from there. At this point, of course, one of the things that I was quite interested in doing was making sure that the gifts that seem to be apparent in my system with mathematics was not just trivialized by people who look at mathematics as some form of abstract thing, you know, that has no use except for some trivial self-gratifying kind of feeling, you know, that you're supposed to get from abstract mathematics. Okay? So, for example, getting that formula, to me, had a lot of practical implications. It isn't just some abstract thing. It has, like I showed, the comparison between that formula and the computer. There is certainly an advantage. So then, I wanted to make sure that people did not misunderstand my role as a person that studies mathematics. I hated being written off as somebody abstract that has no impact on the humanity or practical situations. So I made sure that whenever I develop the mathematics, I would look for an application. This was the first practical part, in terms of, the university years, okay? Because what happened was that, I probably need to cover it. What happened was that the math helped me see rocketry, because this basic book here deals with rocketry, gave me an insight into rocket science. And to, again, get back to my base as an African in terms of where such an idea could have come from. Later on, I would come across the name of Andrew J. Beard, an African born in this country who had no formal education, invented the rotary engine,